files for attachments work for you? Because I'm not getting a clear answer on JPEG, doc, pages. What type of system are you running so that you can open them so that I know what to send you?
On Canvas? You talking about Canvas?
Just anything. What type of files work for you?
Doc files, doc files.
Do JPEGs work?
No, doc files, DOC
Docs
files,
only.
DOC files, Word doc files. If you're going to send them on Outlook, send them as a doc file.
I'm just not understanding how to take a picture of my stuff and store it as a doc file. So that's something I need to figure out, I suppose.
Well, can you do it on Canvas? In other words, we need to somehow get you to, how are you going to upload your test to me? When I send you a test, how are you going to complete your test and get back to me?
That's what I'm trying to figure out.
All right. The way I would suggest you do it is that it's going to come to you on Canvas. I suggest that you complete your test and then attach it back on Canvas. And this thing that looks like a paper clip in the lower left-hand corner is where you attach it on Canvas.
I understand how to attach something. I'm just not, like, me getting something into Canvas, I'm having a difficult time. Sorry, everybody, to take your time on this. This is a one-on-one conversation that should be had at a different time. So I apologize.
Oh yeah, it's confusing for me too.
Yeah, it's a really confusing thing. And I feel like I'm the only one that's like, hey,
This class would be a lot easier in person. I feel like this is more in person.
This has just been difficult because in order to get something into Canvas, you have to do it in a certain way that I'm really not super technically sound at. And so I know we've had emails back and forth, and this has been just very confusing. So I'm just trying to get direct information from you on how to do that, and I'll have to figure it out myself.
Well, I guess there's a couple of ways you can get help. One is the Academic Success Center. The other is for those of you who are sending me all your homework just fine, you end up you have a piece of paper that you somehow take a picture of. Somebody in class that's successfully able to get your homework to me. What method are you using to?
I'm just saying, if you were to make the assignments and put them so that they were due and we could just attach them in the assignment as opposed to doing an inbox straight to you, I don't know. For
It
other
works
classes,
for-
I can explain how I do it.
Okay, go right ahead, please.
So the way that I do it is that I have the Canvas app on my phone, right? So I just take a picture of the homeworks and then inbox it directly to them by just attaching it with like the little paper clip at the bottom.
Right, that's this thing.
Yeah. Have you been receiving mine that way? Like
Yes.
all good?
Yep.
All right, cool.
Yep, I've been receiving everybody's.
So there's no way to turn it in like just on actual assignments. You'd have to inbox it because the rest of my classes is just there's ways to like turn in the assignments on the actual assignment pages with like information about the assignment just in case you can't make it to class.
That also shows that you know that you've turned in that assignment specifically, as opposed to going through all of my emails in my inbox to be like, did I turn this into you and did you receive it?
Anybody else?
Sorry. So what I do is I make like a screen because I do it all digitally. So I send it to you doing like a PNG, so like a picture file. Is that okay instead of a doc?
You're let me see, Ruthie. Let me just check here, make sure I've got them all here before. Yes, I've received all yours, Ruthie. They've all come in just fine.
So it can be something other than a doc form.
As long as I can open it and read it, yes.
All right, thanks.
What you've sent me so far, I've been unable to open. So I'm not sure what you're sending, but anybody, yours is the only one out of 2 classes. 80
okay,
people.
So can we have a discussion afterwards, after class, after the open hours, so you and I can figure out what is in and what's not on our own time, please? Thank you.
Yeah. All right. Any other questions before we start today's work? Any homework problems that we should be reviewing? Okay. The plan today is to cover section P.5, P.6, and P.7. So let's go ahead and get that work here. P.5 talks about factoring polynomials. And by factoring polynomials, we're going to do several things. We're going to factor out the greatest common factor. We're also going to factor by grouping. We're going to factor trinomials. We're going to use the difference of squares. We're going to factor perfect square trinomials and sum and difference, 2 cubes, general strategy for factoring polynomials, and factoring polynomials with fractional and negative exponents. So that's what we want to do as a result of this section. So let's take a look at a couple of examples that hopefully will step us through that for you successfully. If, for instance, I have 18x cubed plus 27x squared, and I want to factor out the greatest common factor, then I can look at the leading coefficient here, and I can see what the factors are of that. 1 and 18, 2 and 9, 3 and 6. Okay, over here,
Can
1.
you center your page, please?
Yeah, can you see that? Everybody see that okay?
Yeah.
Okay. 1 and 27, 2 won't divide, 3 and 9, 4, 5, 6. So it looks like we can use those factors. And now we're looking at the greatest common factor for these leading coefficients. And 18 and 27, 9. Looks like 9 is a common factor, and looks like that's the greatest common factor. So we're going to have 9. And then from x cubed and x squared, well, we have an x squared within this x cubed, don't we? So we can take out the x squared. And that leaves us what? 9 times 2 and an x. So that gives me 9x squared times the quantity 2x plus, and I'm going to multiply by what? By this guy here, 3 times 9 is 27x squared. So I can just say 3. So now, once I have factored, I should end up with 9x squared times 2x plus 3. Questions on that? Okay.
How did you get the 2x plus 3 again?
Good question. Let's see. 2x plus 3. Well, when I factor the leading coefficient 18, I ended up with 9. That's this value here. And then I take out the x squared. That's this value here. So if I cover up this and said 9x squared times what? 9x squared times what gives me 18x cubed plus x squared. I have to figure out what I have to put into here. So 9x squared times what gives me 18x cubed? 9 times what gives me 18?
2x.
2. X squared times what gives me x cubed?
X.
X. And the second term. What do I need to do to get, what do I have to get over here? 27x cubed. I guess that should be this value here, 27x squared. So 9x squared times what goes here gives me 27x squared. 9 times what gives me 27? Well, that'd be 3, wouldn't it?
And 3.
Yeah. So 9 times 3 is 27. This is x squared, so I don't need anything else. So what I'm looking for is this value here, 9x squared times the binomial 2x plus 3. that would be it here. Makes sense?
Yep.
Okay. Let's do something called factoring by grouping. When I factor by grouping, I use that when I have, for instance, 4 terms. I might have x cubed, and I'll list these in descending order of exponents. Plus 4x squared plus 3x plus 12. So I've got a polynomial, 4 terms, and I want to factor this by grouping. So first thing, list them in descending order. Second, let's put them in groups of 2. So when I put them in groups of 2, and then I factor the first group. Well, my leading coefficient is 1 and 4. Really can't do anything with that. But then the next variable is x squared and x cubed. Well, I can factor out an x squared, can't I? Because there's an x squared here, x cubed here. So I can say x plus 4. And I can test that. X squared, distribute the x squared through this polynomial, this binomial. X squared times x is x cubed. X squared times 4 is 4x squared. So that works nicely. Plus, well, there's no x over here, so I'm not going to factor out an x. There's a 3 here, and I can find a 3 as a factor of 12, can't I? 3 times 4 is 12. So I can factor out a 3. X plus, factor out that 3, leaves me a 4, doesn't it? So now I have, when I factor by grouping, I have x squared times the quantity x plus 4 plus 3 times the quantity x plus 4. Well, that's good, because look what I have here, an x plus 4 in both of those terms. So I can factor out the x plus 4. And what remains is the x squared plus 3. So then my solution becomes x squared plus 3 times x plus 4. And that's called factoring by grouping. Okay, questions? All right, let's factor a trinomial. Let's say I have x squared plus 3x minus 18. And I want to factor that. Take a look at the leading coefficient, and that's 1. So if I factor this into this trinomial into 2 binomials, which I can then FOIL to get back to this trinomial, leading coefficient is 1. So that says I can put an x there and an x there. X times x is x squared, first times first. Now, last times last, I need factors that multiply to get 18. Well, that could be several things. That could be 2 and 9 or 3 and 6. But I need, when I multiply the outer and the inner together, I need them to add or subtract to make 3. Well, 9 plus or minus 2, that doesn't give me a 3, does it? 9 plus 2 is 11. 9 minus 2 is 7. So that doesn't work. 6 and 3, 6 plus 3 is 9, but 6 minus 3 is 3. So that works. So I can put a 6 and a 3 in here. And then I just have to worry about what the signs are. Well, this negative value says that the signs are going to be opposite, because I can't multiply 2 values together and get a negative value unless the signs are the opposite. So then I look over here and say, well, which one is the larger? And this says, well, the larger must be 6, because when I add those together, 6 and 3 gives me a positive 3. So let's FOIL it and verify that it works. First times first is x squared. Outer is negative 3x. Inner is positive 6x. Combine those gives me a positive 3x, which is what I have here. And then last is 6 times 3, and it's negative, so that's negative 18. So my solution then looks like this. Okay, questions on that? What we did
Did you do
there?
like another problem like that? So I can fully understand it.
Sure. Let me get some paper over here. Let's try 8x square. Let me see, let me adjust this camera here. There we go. 8x square. And I want to, let's say I want, let's say negative 10x, negative 3. So this is a trinomial, and I'm looking to factor. And I say, well, you know, the leading coefficient's not 1 here. Well, what are the possibilities? Well, we could have a 1 and an 8 or a 2 and a 4. That would work, wouldn't it? And over here, a 1 and a 3 would work. Okay, it could also be the other way. It could be 1 and a 3 that way. And then when I do this, I start here and here. And I say, well, if I multiply first times first, that's 8 times 1, that's going to work. But I need to multiply outer, which is 8, and inner, which is 3. 8 plus or minus 3, does that give me a 10? And the answer is no. So that doesn't work for that iteration. So let's go down to here. 8 times 3 is 24. 1 times 1 is 1. 24 plus or minus 1, that doesn't give me a 10, so that didn't work either. So we go down to the next one, and then we start again. Go up to here, 4 outer, 4 times 1 is 4, and then 2 times 3 is 6. That might be plus or minus. Well, if I add 6 and 4, I do get a 10, so that works nicely. So I say, well, let's put these values in. Here's a 4x, and here's a 2x. And once I've got 4x and 2x, I take a look at here and say, well, looks like 3 and 1 might work. Does that look like that's true? Well, let's see, 3 and 1. Well, that might not work. Let's see, 4 times 2 is 8x squared. That's good. That works. But outer is 4. Well, that looks like that might work. But these need to be opposite signs because we have to multiply to get a negative. So the signs have to be the opposite. And the larger, when we multiply, is going to be a negative 6. Excuse me, a negative value here. So if I put 2x and I say, well, let's see if I do outer, let's see if this works. That's 4x, and inner is 6x. And 1 is negative and 1 is positive. Is that going to work for me? So if I look at that, does that look like that's going to work? What do you think?
I think it will, because it gives the 10x.
Well, let's try it. So the question is that good? So let's test it and see. First times first. First times first is 8x squared. Outer is 4x, inner is 6x, and last is 3. Now I don't have signs in here. This says the signs are opposite, and the larger is going to be negative. So if I look at this, 6 is larger, so that looks like it would go like that. So if I FOIL this, that's 8x squared, that's negative 3. And then here I've got positive 4 on the outside and negative 6. Well, that's not going to work, is it? Because we've got 8x squared plus 4x minus 6x, that's negative 2x, negative 3. So that didn't work. So something isn't working for us here. We have to take a look. What did we do wrong? Well, let's take another cut at this thing. 8x squared minus 10x minus 3. Now my 4 and 2, let's say I keep that, and I have the 3 and 1, and I keep that. Now, did I fill in these values properly? Well, let's see. We need a 4 and a 2, if I put 2x and 4x, and I put in -3 and +4, now what happens? Now I get there a different way, don't I? Because now when I do FOIL, first times first, 2x times 4x is 8x squared. That's good.
It'd be +1, Professor, in the second parentheses.
Oh, I'm sorry. Saying 4 too many times. Thank you. So that's first. Outer would be 2x times 1. That's 2x. Inner is -3 times 4. That's -12x. That combines to be -10x, which is what I was looking for, isn't it? And then last is -3 times 1 is -3. So it looks like here is the solution. I needed to change the location of the values that I was determining. That's the only thing that was wrong. So when I finished, I ended up with 2x minus 3 times the quantity 4x plus 1. Could be in either order. I mean, A times B equals B times A, doesn't it? Okay. All right. If there are no questions, I'll go to another one. Let's take A. No, let's not do A. Let's take another one. Let's take this one, x squared minus 4. So here we're factoring the difference of two squares. Okay, we're factoring the difference to two squares. So this looks like a squared minus b squared. If we let a equal x and we let b equal 2, that would look like x squared minus b squared, which is this, okay? Do you remember what a squared minus b squared looks like when we did that before? When you did that in maybe 97 or Math 98 or Math 99, and we ended up with a plus b and a minus b. Do you remember that? And if we FOIL this, first times first is a squared. Outer is negative ab. Inner is positive ab. And last is negative b squared. So this negative ab positive, it cancel, don't they? So if we let x squared minus 4, if we are going to factor that, that's going to look like x plus 2 times x minus 2, isn't it? First times first is x squared, last times last is negative 4, and the outer and the inner cancel. So we're going to look like this as a solution. Make sense? Questions?
Could you repeat that last part?
Yeah. We put in x plus 2, x minus 2, and then we can FOIL it. Is that where you want me to start?
Just where you got the numbers for the last part. I just kind of got lost for a second.
Okay. Let's say we have a squared minus b squared. And what do we know that to be?
A plus b and then a minus b.
Very good. So we're letting a be x and b take on the value of 2. So a is x plus b takes on the value of 2, and a takes on x minus b takes on the value of 2.
Oh,
X plus
okay.
2, x minus
Yeah.
2.
I got it. For some reason, I thought that 2 was the exponent.
No. The
Yeah.
x, okay. The
Yeah,
exponent,
got it.
okay, very good. The exponent we get when we take first times first, we get x squared. Last times last, we get negative 4. And the outer and the inner, when we multiply those and add them together, those cancel out.
Yeah.
Now, this is one we want to memorize. We want to make sure that you have in your memory this one here, because this is used many times. So make sure that if you can recognize something as a squared minus b squared, that you know it looks like this. Or if you're going the other direction, if you say a plus b times a minus b, you know you're going to get that value. Okay. All right. That one's kind of messy. Let's take this one. Let's say I have, well, let's do cubes. Let's see if that doesn't work for us. What if I have a cubed plus b cubed? Have we seen that before? And I think the answer is yes. I think you've probably seen this in math 97, 98. This is going to end up being a plus b times a squared minus ab plus b squared, isn't it? So if that's the case, then if we gave you the value x cubed plus 8, we want to look at this as the same as, well, we let a equal x and b equal what? What would we have to let b equal? A equal x, b equal what? To make
Square root
this
of 8 or 2.
2. Cube root of 8, right?
Yes.
Yeah, cube root.
Cube root of 2. Okay.
Thank you.
So given that's the case, then we could say x cubed plus 8 could be reduced to, when we factor it, a plus b. So that's x plus 2 times a squared, that's x squared, minus what, 2x plus 4? Is that what we end up with? Everybody agree on that?
Yes.
Yeah.
Or is this going to be something else? I don't want to lead you down the garden path here, but I just want to make sure that we all agree on what that's supposed to be. Is that supposed to be 2x?
Isn't it? Actually, yeah, it's 2x. Never mind.
Okay, good. And we could verify by simply distributing the x through this and then add to that when we distribute the 2 through this, add those like terms together, and we should get x cubed plus 8. And you can verify that on your own if you'd like to do that. One other thing I'd like to point out is the signs. This positive sign, this negative, and this positive. To make sure we have those signs properly, we can say, well, this is positive. And over here, we have an acronym that we can use. This sign is always the same as the original sign. This sign is always the opposite of the original sign. And this sign is always positive. So our acronym is SOAP, or SOAP, saying that these are the signs: same, opposite, always positive. Okay, so here is the solution when we factor that. Okay.
Wait, so during these problems, is A always X and B always 2? Or am I missing something on this?
No, I just substituted because I used this here. Because I
okay.
used a cubed plus b cubed. Now down here I had x cubed plus 8. I could have said z cubed plus 27. So in this case, a would equal this z value, and the b would equal what?
3.
3. 3 times 3 is 9
okay.
times 3 is 27.
Got it. Thank you.
Excuse me, what was P?
Which was, what was b?
P.
B, oh, this here? That's always positive.
So if that x to the third was an x to the third minus 8, it would then go to
X to the third minus 8. Well, let's just do it. This one is plus. Let's take a new problem. X cubed minus 8. All right. If we let A equal X and we let B equal 2, then how can I write this? Could I write that as x cubed minus 2 cubed? Is that the same?
No, because of the minus x cubed is a negative, or that would work actually.
This is a 2. This is not an x. This is a 2. This is x cubed minus 2 cubed. And the question is the left-hand side equal to the right-hand side? Which really says, is 2 cubed equal to 8? Is 2 times 2 times 2 equal 8?
Yeah, this is a correct statement.
Yes.
It is correct, isn't it? So those are the same. So if this is the same, we know that this could be written as a cubed minus b cubed. And a cubed minus b cubed we've already done. We said it looks like this. And this is another one of those. This is a cubed plus b cubed. If we do a cubed minus b cubed, we're going to end up with a cubed minus b cubed. What did we say that was? Or have we done that one yet?
You're just going to swap the signs like you were talking about above to use the acronym. So you'll have a minus b and then the rest of it. So a squared plus ab plus b squared.
Okay. All right. So
All you're doing is swapping those two signs above where you showed.
okay.
Thank you. That was my question.
All right. Very good. Let's do this. Let's see if we can factor a polynomial. If I give you 2x cubed plus 8x squared plus 8x, and I ask you for the greatest common factor, do we know enough in order to factor this trinomial and pull out the greatest common factor? And if so, what would we get when we do that? You go ahead and take 30 seconds and go ahead and work that problem.
Wouldn't the greatest common factor be 2x?
Well, the greatest common factor from the 2, 8, and 8, would that be 2?
Yes.
And the greatest common factor of x, x squared, and x would be something that's common. That would only be the x is common, isn't it? So that would be 2x. So if we say 2x is the greatest common factor, what's left after we do that? If I say the greatest common factor times what's remaining?
It would be x squared plus x. I'm sorry, plus 4x plus 4.
Okay, everybody agree? And then we can distribute this 2x to verify 2x times x cubed is 2x cubed times x squared. 2x times 4x is 8x squared. 2x times 4 is just 8x, isn't it? So that's what we get when we factor the greatest common factor out. And we get something that looks like that. Okay, very good. Very good. Let's see. How about if I gave you something that looked like x squared minus 25a squared plus 8x plus 16. Now, what are we looking at here? So let's see. Well, this a squared, that doesn't look like it fits. This is x, x, and x. So let's move that out. So x squared plus 8x plus 16. And let's move this to negative 25a squared. Let's move that out here. Now, are we able to factor this trinomial? If so, what do we get?
X plus 4 squared.
X plus 4 times X plus 4, or X plus 4 quantity square. Okay. And then this second term over here is negative 25 A squared. So now do we put a box around it, put an arrow to it and say we're done, or can we simplify further? What do you think? Anybody?
We're gonna have to further.
Okay. X plus 4, we're going to call that quantity square minus. Now this looks like it could be rewritten as
5A squared.
5A quantity square like that. Okay.
Yeah.
But now we have something squared minus something squared. A square minus B square. Sort of looks like that, which we said was A plus B and A minus B. So can we factor this? And if so, what is that going to look like?
Is it X plus 4 minus 5A times X plus 4 plus 5A?
Sure, why not? So here we have X plus 4 times X plus 4, X plus 4, X plus 4 minus, and what do we have here? That's the same thing, isn't it? That's just 5A times 5A. So
we could just write it as X plus 4 plus 5A and then another parentheses, and we would do X plus 4 minus 5A.
yeah, let me make sure what we're doing here. When we better step back here. When we did this here, did we expand this? What did we expand this to? X plus 4 gave me what?
X squared plus 8x plus 16.
Now let's see.
That's where we were working from, Professor. So we're where we need to be. We just need to identify A as X plus 4 and B as 5A.
All right, let's do that.
Identify those variables.
So let's do that. Let A equal X plus 4, and we'll let B equal 5A. So now we have A square minus B square equals what we said before, A plus B, A minus B. And so if we let A as X plus 4, we have X plus 4 plus B, which is 5A, isn't it? Times A X plus 4 minus B, which is minus 5A. Okay, so now we have X plus 4 plus 5A times the quantity X plus 4 minus 5A. And that's where we're going to stop, isn't it? That makes sense what we did there? Same concept we were using before. We're just using different values. Okay? Other questions? Okay. I think I'm going to stop right there on section P.5 and make sure we've got enough time to cover P.6 and 7. So what I'm going to say is, if there are further questions on P.5, let's save those until after the class, and we'll take those questions during the office hours after that. And let's move on then to P.6. In P.6, we're talking about rational expressions. P6 is rational expressions. And what we're going to do is take a look at the objectives are to specify numbers that can be excluded. So we're going to find out that we're going to solve some problems, but some of the values we're going to have to exclude for X. We're going to look at the domain of a rational expression and we're going to simplify them. We want to multiply, divide, and add and subtract them. And we want to look at simplifying complex rational expressions, simplifying fractional expressions that occur, and rationalizing numerators. So we want to look at all these concepts in P.6 rational expressions. And the first thing we want to talk about is what exactly is a rational expression. And a rational expression is going to be something that looks like A divided by B. Okay, it's a quotient. And so if, for instance, I have, let's say 4 over x minus 2. So if that's the value that I'm saying is my rational expression, if we were to go through a series of operations and then say, here's my solution, are there any values that need to be excluded? Are there any values that you can see that would need to be excluded? And why would we need to exclude them? Well,
2 would need to be excluded because it causes us to divide by 0.
Right. So we cannot have an x equal to 2, can we? We have to exclude the value x equals 2, because if x were 2, we'd have 2 minus 2, which is 0, can't divide by 0. Okay. Another term might be if we have, look at 9x over x squared plus 3x minus 18. And I'm looking for the same thing. Are there any values that need to be excluded? And we'd say, well, let's go ahead and factor this denominator and see what happens if we set that equal to 0. So we'll have 9x over, if we factor the denominator, we're going to end up with x and 6 and 3 and positive and negative. And we can FOIL that to make sure that these are the same. Then we're going to set this denominator equal to 0 and solve for x. So we'll have x plus 6 equals 0 and x minus 3 equals 0. So x equals negative 6 and x equals 3. And that says that we must exclude the values x minus 6 and x equals positive 3. We have to exclude the negative 6 and the positive 3, because if x were negative 6, that would cause this value to go to 0, which would cause the denominator to go to 0. We can't do that, can we? Okay, if we put an x as positive 3 here, that would also cause the denominator to go to 0. Okay, so we just have to make sure that we don't have any solutions that we haven't excluded values that cause the denominator to go to 0. Okay, so we're going to say, hey, that's a fine solution. We can leave it at that, but we just have to make sure that x doesn't equal these values. Okay, I might have something like x cubed, let's say x cubed plus x squared, or x plus 1. And here, say, well, can I factor that numerator? Well, I've got an x squared and an x cubed, so I could make that x squared times what? X plus 1. X squared times x is x cubed. X squared times 1 is x squared. That's good. Over x plus 1. So if I'm asked to simplify, this polynomial or this quotient, then I'll say, well, by factor, they each have a x plus 1 in the numerator and the denominator. I can get rid of those and say my solution is x squared, with the exception that x equals negative 1 is excluded. Because if x were equal to negative 1, the denominator would go to 0. Okay, so here's our solution. It's not only x squared, but it's the excluded value of x equals negative 1 must be excluded. Okay, questions?
Could you do another problem like the 9x over x squared plus 3x minus 18? Could you look another problem like that?
Like this one
Is
up
it
here?
Like you scroll a bit.
Like the
Yeah,
top
something
one?
like that. Yeah, I have trouble on that thing.
Well, what if I had
Or you can explain it more.
what if I had x squared minus 2x minus 8 over x squared minus 9 on something like that? We're always going to do the same thing, aren't we? I mean, what we did on here in this problem was factor and then decide what values caused the denominator to go to 0. And that was -6 and +3 caused the denominator to go to 0. That's always what we're looking for. So in any problem, say like this problem, we want to say, can we factor this and simplify such that we don't get a 0 in the denominator? So let's just take a look. If I say x squared plus 2x minus 8, and let's even make it more interesting. Let's say we divide this by x minus 4 and x plus 3. So here we're just going to factor and simplify. But let's make it more interesting by dividing by another rational expression. Well, let's just do this. Let's start with this term here. If we factor x squared minus 2x minus 8, we're getting pretty good at our factoring. So we're going to say that's x and 4 and 2. And we're going to call this negative because it's the larger and positive. And then we can always FOIL to make sure x times x is x squared. Last is negative times the positive, which is a -8. Outer is 2. Inner is -4. That gives us a -2. So that works. X squared minus 9 looks like a squared minus b squared, or a x cubed minus 3. So that look minus 3 quantity squared. So that's going to be x plus 3 and x minus 3, isn't it? So now we've factored this left term. Now we know that we could put this division under here and make this a over b or whatever we want. But we don't want to divide that way, do we? We know that we want to invert this divisor and multiply. So let's just go ahead and do that. So we invert and multiply, and we get x plus 3 over x minus 4. We just invert this. Okay, so when I invert that and multiply, I get the following. This quantity, this quantity. So I go along here. Let's just take the first binomial, x minus 4. We say, does that exist in the denominator anywhere? Because if it does, we can cancel it. Not here, not here. Ah, it exists here. So we can cancel that, and we can cancel that. Good. Now, how about x plus 2? Does that exist down here? No, that's fine. How about x plus 3? Oh, that exists here. So x plus 3, that goes away. And by canceling, so now we're left with x plus 2 divided by x minus 3. So when we simplify, this is what we get, x plus 2 over x minus 3. But we need to take care of the excluded values. And we can take a look here where we have done the factoring and say, set each of these equal to 0. X plus 3 equals 0, or x equals -3. So exclude x equals -3. Okay, we also have x minus 3, set that equal to 0. So x equals +3, we also exclude, because that would send this denominator to 0. Over here, we have x minus 4. If that went to 0, x would equal 4. So we have to exclude x equals 4. So this says the solution is x plus 2 over x minus 3, excluding the values x minus 3, x plus 3, and x equals 4, because if x were equal to any of those values, these denominators would go to 0, which would cause this value to become undefined. Okay, questions on that at all? Anything we did there
Can you
confusing?
explain why you inverted the x minus 4 over x plus 3 again?
Yeah. If we have A over B and we divide that by C over D, we want to know how we do that. And we do it by invert, and then we multiply. So C over D becomes D over C, and as a multiple. So that becomes AD times BC. If you want to put numbers in to verify, we could put whatever numbers we want. We could put 4 over 2 divided by, we could say divide it by 4 over 2. We could put in any numbers we want, right? So 4 over 2, and if we invert and multiply this, that becomes 2 over 4. So those 2's cancel, those 4's cancel, and the answer is 1. Well, let's just, without doing the invert and multiply, 4 over 2, that's 2. And in the denominator, we have 4 over 2, that's 2. 2 divided by 2 is 1. So that confirms that our solution is 1. We get there different ways. One we invert and multiply, one we actually do the divide. But in the problems we're looking at with our binomials, we can actually do the divide, can we? Because we have variables in there for our values. We have x's instead of an actual number. But the methodology works. The methodology of inverting and multiply, that concept works. That answer your question? Any other questions?
I have a question.
Yeah, go right ahead.
I'm wondering, I'm still a little confused on like knowing which values to like exclude.
Oh, we exclude a value if it sends the denominator to 0. If the denominator becomes 0 by including a value of x, then we can't have that. If I have 1 over x minus 3 as our solution, if we say, hey, that's what we ended up with. Well, let's say, okay, let's try this for different values of x. X equals -1. Does that work? Well, 1 over -1, -3 is 1 over -4. So 1 over -4. That works okay. How about x equals 0? X is 0, we get 1 over -3. How about x equals 3? Well, that's 1 over 3 minus 3. Well, that's 1 over 0. Can I have a 1 over 0?
No,
Why not?
No.
because the answer is undefined.
Because we can't divide by 0, can we?
Mm-hmm.
Okay, so that's undefined. We can't divide by 0. So anything that causes this denominator to go to 0, that value of x cannot be allowed. And that's really all we're saying here. That makes sense to everybody? Questions?
Thank you.
Sure. All right. Shall we keep going? All right. Let's see. What would be another good one here? What if I have 5x plus 1 divided by x squared minus 9. And I want to subtract from that 4x minus 2 divided by x squared minus 9. Now what we're doing here is we're subtracting a rational expression from another rational expression where the rational expression is a over b. a quotient. Now you notice we're doing a subtraction where the denominator is the same for each of these quotients, for each of these rational expressions. So since the denominator is the same, I can rewrite this x squared minus 9 in the denominator. And what's my numerator going to be?
5x plus 1 minus 4x plus 2.
Yes. Well, let's see. 5x plus 1, that's that, minus applied to this binomial, minus 4x minus a minus 2 is a positive 2. Okay. So let's simplify the numerator. 5x minus 4x, that's just what? X, and 2 and 1 is 3. So is that an x plus 3 in the numerator? And in the denominator, when I factor x squared minus 9, what am I going to get?
X plus 3, x minus 3.
X plus 3, x minus 3. And then we say, can I simplify? I have an x plus 3 in the numerator, x plus 3 in the denominator. Those cancel, and I get 1 over x minus 3 as my simplified solution. That's good.
I have a question.
Yes. No, we're not. Let me finish up and then we'll take your question. But I have to exclude what? I have to exclude any value of x that causes the denominator to go to 0. So what value of x would cause the denominator to go to 0?
Plus or minus 3.
Plus 4 minus 3.
No, plus or minus 3.
Oh, or plus
So
or minus
have-
3.
Yeah.
Okay, and what this just says x minus 3. So if I said x minus 3 equals 0, I said I get x equals positive 3. Where do we get the negative 3?
From the step before that, where you have x plus 3 over x plus 3 times x minus 3. Don't you still have
Yes.
to account for both of those values?
Yes, we do. Yes, we do. So we set x plus 3 equal to 0, and we set x minus 3 equal to 0. We've done the x minus 3. If we set x plus 3 equals 0, we get x equals negative 3. So then we exclude,
Could you move the paper down just a little?
sure, we exclude x equals plus or minus 3, or these values here.
Why is minus 3 excluded?
Because we had up here, we had in the denominator x plus 3 and x minus 3, and we set that denominator equal to 0. And when we do that, x plus 3 could equal 0, or x minus 3 could equal 0. That is, if we have a times b equals 0, then a can equal 0, or b could equal 0. And so we have to set both of those equal to 0 and solve for x.
You can also plug either plus or minus 3 into the original equation, and you'll see that if it substitutes for x in x squared minus 9, you're going to get 0 either way. So plug it back into the original equation and double check. If
You can do that as well. You can do that as well. Okay,
Also,
other,
a quick question. What's
Yeah.
the homework for next class? Is it the same like last 10, every other odd for P5, P6, P7?
yes, and I have also added those exact problems you should work so that you don't have to figure it out. So when you look in the assignment section, it'll show problems. For instance, it might show 89 to 125 or whatever, and then it'll have a parenthesis and it'll show you what problems to work. 89, 93, like that.
Okay, thank you.
Sure.
The thing I was a little confused on was
Yes.
at first it says 5x plus 1 over x x squared minus 9 and stuff.
Yes, here. Mhm.
But when you added like the numerators together, it seems that negative 2 became positive 2.
Yes, it did.
Can you explain why? Because I
Yes.
thought we were adding like the numerators together.
Yes, we
then-
are. So we're here, this 5x plus 1, that's here. There's
Mhm.
5x plus 1. And then this negative is times this numerator.
Okay.
So negative times a 4x is a negative 4x.
Mhm.
And a negative times a negative 2 is a positive 2.
Mhm. I understand now. Thank you.
So negative times the quantity 4x minus 2 equals negative 4x plus 2. We distribute this negative across the parenthesis. That make sense? Questions?
Yes, thank you.
Okay. All right, it's about 4 o'clock. I think I'll stop right here and we'll take a 10-minute break. We'll resume at 4:10 and we'll continue with P.6 and then we'll finish up with P.7. Okay? We'll see you in 10 minutes.
Recording stopped.
Okay, are we back? Any questions come up at the break? No questions? Okay. Let's see. Here we had a common denominator. Let's take one without a common denominator. Let's see what that might look like. So if I had x plus 2 over 2x minus
Recording in
3.
progress.
From that, we subtract 4 over x plus 3 and maybe set that equal to x plus 2 over 2x minus 3. Let's see. Is there anything else here we need to do with that? Well, let's tell you what, let's just simplify. Let's just say we've got this. And if I want to create a common denominator, I've got 2x minus 3 here and x plus 3 here. So I'm going to need to have an x plus 3 in this denominator to pick up this. And if I multiply this denominator by x plus 3, I'm going to have to multiply the numerator by x plus 3, aren't I? So that'll take care of that side. On the right side, I need a 2x minus 3. So I'll put a 2x minus 3 here. And I have to multiply by 2x minus 3 in the numerator. All right, so far, so good. So let's go ahead and do the multiply and see what we get here. We know we have our common denominator. We're multiplying there, so let's just see here. For the numerator, I'm going to FOIL this thing, aren't I? So x times x is x squared. Outer is 2x, inner is 3x, so that's plus 5x. And last is 6. And from that, we want to subtract 4 times 2x, that's 8x. And 4 times 3, that's going to be a negative 12, isn't it? So it's a negative 8x positive, negative 12. And then in the denominator, if I distribute this x plus 3, 2x minus 3, I'll end up with 2x squared plus, let's see, outer is negative 3x, inner is positive 6x. That's going to give me a positive 3x, isn't it? And then a negative 9. So far, so good. So if I distribute this negative, that'll give me a negative 8x and a positive 12 on it. So I've distributed this thing into here. So now for the numerator, I've got x squared. And then I've got 5x and a negative 8x. That's a negative 3x. And I've got 12 and 6. That's a positive 18. And in the denominator, I've still got this thing here. I guess we could 2x squared plus 3x minus 9. So now I have a polynomial over a polynomial. So let's see if we can factor the numerator and the denominator. Can we do that? Well, let's see. Can we factor the numerator? Let's see. We have xx 18. Well, that could be a 6 and a 3, but if this is positive, they both have to be the same sign. And I can't have the same sign and get a 3 over here, can I? So I'm not going to be able to factor that in that normal method. So x squared minus, I'm going to leave that, plus 18. So that's my numerator. see if we can factor the denominator. See what, no, I'll put it down here. Let's see if what that can become. So if I had 2x and x, and here we have a 3 and a 3 will give me a 9. And let's see, 2x, let's see, this is a negative, so the signs are opposite. The larger is positive. The larger I get when I do outer, 2 times 3 is 6. That's larger than 3. So I'll say 2 minus 3, 2x minus 3, and x plus 3. So I get this as a solution when I subtract these values. But then I have to exclude any values that send this denominator to 0. So how am I going to calculate that?
Set each of those equations equal to 0. Yeah.
Yes. X plus 3 equal to 0. So x equals 3 over 2. And x equals negative 3. So these are the excluded values. Okay. Okay, so let's see here. We have an answer. We have excluded values. Is there anything we've left out? Are we doing okay then? Is this the correct answer? Are we done? Okay, I think we are. I think we did that one. All right, let's see if we can combine x plus 3 over x squared plus x minus 2. And we want to add that to 2 over x squared minus 1. So what we're doing is we're adding values with different denominators. Okay, so we want to add this value to this value, but we notice that these denominators are different. So the question is, can we somehow get those denominators the same? Well, if we factor this one, or maybe we should say, can we factor it? X and x gives me x squared. 2 and 1 will give me 2. This says the signs are opposite and the larger is positive. The larger is a 2x, so I'll call that positive and that negative 1. And over here, this looks like a squared minus b squared, doesn't it? So that looks like x plus 1 times x minus 1, a squared, b squared. So let's see, here we have an x minus 1, here we have an x
Can you
minus
move
1.
the paper down?
Yes. How's
Thank
that? Does that work?
Yeah.
Okay. Let's see. So if I x plus 1, x minus 1, x minus 1, I need an x plus 1 here to match this. Also x plus 1, and I'll need to put that in the numerator as well. And then I have an x plus 2 here. So I'll need an x plus 2 here, an x plus 2 in the numerator. So here's my common denominator, and here's my numerator. So if I rewrite that with a common denominator, x plus 1, x minus 1, x plus 2, and now let's sum up the numerators. X plus 1 and x plus 3. So if I multiply those by foiling, I'll get x squared plus 3x and 1x. That would be 4x, wouldn't it? And what else do I need to do? This over here, 2x plus 4. Okay, so it looks like I have x squared plus 4x plus 4. If I've done my 4x into 6x, so I get x squared plus 4x into x, 6x plus 4 over x plus 1, x minus 1, x plus 2. 6x plus, that's not 4, is it? What is this? What should that be? What do we have? What do we have over here? X squared
I
plus.
think there should be another like 3 because when you multiply it out to get x squared plus 4.
Yes, yes. This 3 here, I left out this 3, didn't I? So that's 3 plus 4. That's going to give me a 7, isn't it? 3 and 4. To give me that 7. So it looks like I have x squared plus 6x plus 7 over x plus 1, x minus 1, x plus 2. So when I combine those, that's what I get. And then I have to say, what must be excluded? And when I exclude, I set the denominator equal to 0. So if I set x plus 1 equal to 0, solve for x, I'll get x equals -1. That has to be excluded. Set this value equal to 0, and I'll get x equals +1. That has to be excluded. And set this value equal to 0, and I get x equals -2. And that has to be excluded. So when we do our combining, the adding of these quotients, of these rational expressions, we get x squared plus 6x plus 7 over the quantity x plus 1 times x minus 1 times x plus 2, and we exclude x equals ±1 and x equals -2. Okay, questions?
So why didn't we further simplify the denominator?
The denominator here?
Yes.
And what was your question? Can we do what?
Can't we multiply it further and it will become like x cubed and something then?
Oh, well, we could, but that wouldn't do us any good because what we're trying to find out is what can be excluded or what must be excluded. And we have to factor it in order to find out what must be excluded so that we can solve for this x and this x and this x. So we want to leave it in this form. And then we say x -1, x +1, x -2 are the excluded values.
Okay, thank you.
All right, let's try. See if I've got room on this paper right here. Let's say I have, now I'm going to get a different piece of paper, get some more room here. Let's say I have 1 plus 1 over x divided by 1 minus 1 over x. So we're simplifying a complex rational expression, complex meaning that it's got a fraction here included in the numerator denominator. And we want to simplify this by finding the least common value for the numerator, which is up here, least common denominator for the numerator, and we want to find the least common denominator for the denominator. So we want to do two different computations here. So in order to find the least common denominator for this numerator portion up here, what am I going to do?
Solve for x?
Well, what I want is I want a denominator for this 1 that has an x. In order to do that, if I put an x here to make that the common denominator, I have to multiply by x in the numerator, don't I? So that the numerator becomes x over x plus 1 over x. And I want to do the same kind of thing in the denominator. Multiply numerator, denominator by x. So I get x over x minus 1 over x, like that. Okay, so far so good. So the numerator I can simplify as x plus 1 over that common value of x. And the denominator becomes x minus 1 over the common value of x. Okay, now I have a fraction over a fraction. And what do I do in that case? What do I do to resolve this?
Invert and multiply.
Invert and multiply. So I'll invert this to x over x minus 1. So this becomes this. So now I'm simplifying this, and x, those cancel. So that leaves me x plus 1 over x minus 1 as my solution. I'll put a box around it, put an arrow to it, and say that's my answer. But then I have to say, are there any excluded values? And we take a look here and we say, well, in the numerator, I have an x minus 1 here as a denominator. So x minus 1, if that were to go to 0, let's say x equals 1. So we have to exclude x equals 1. And is there any other value that we need to exclude? And we can say, well, you know, we're dividing by x here. So we have to exclude x equals 0 here as well, don't we? Because we're dividing. We're dividing all these places. We're dividing by x. So we have to exclude x equals 0 as well. So we can say our solution becomes x plus 1 over x minus 1, excluding x equals 0 and x equals 1. Okay, questions?
Could you explain why you have to like times x in the beginning?
Which step here are we talking about?
I think the first problem is like x times 1 is like x times 1 as well.
Over here? Over
Yeah.
here? Okay. We'll separate that out to a separate problem. 1 plus 1 over x. If we want to add those two terms, then they both have to have the same denominator, don't they?
Oh, okay.
And this denominator is 1. But it needs to be an x. So I'll multiply it by x. But whatever I do to the denominator, I have to do to the numerator to keep the ratio the same. So now I have x over x plus 1 over x. X plus 1 over x. Okay, and that's what we had up here. That's what we had up here. Okay, other questions? Okay, let's say I have, let's see what example would be a good one here. Let's say I have root 9 minus x squared plus x squared over root 9 minus x squared. And I want to simplify this fractional expression. And I want to simplify this one. And the concept that's different here is that this has radicals. So really, I'll put this over 1. So I want to combine these. And in order to combine them, I need a common denominator, don't I? And let's take it one step further. Let's say this is divided by 9 minus x squared, just to make it more interesting. So we'll do it step at a time. Denominator is 9 minus x squared. That's easy. Numerator, well, we need a common denominator up here. So it looks like we have 9 minus x squared, the root of. So I'll take root 9 minus x squared and multiply numerator 9 minus x squared. So 9 minus x squared times 9 minus x squared, what's that going to give me?
9 minus x squared.
9 minus x squared. Those roots will go away, won't they? Plus x squared divided by root 9 minus x squared. That's the common denominator. And that's all over 9 minus x squared. Okay, now we want to continue simplifying. So in this numerator, I have 9 minus x squared plus x squared. So it looks like these are going to cancel. So I'll get 9 over root 9 minus x squared. And that's all over 9 minus x squared. Now, can that be simplified further? Can I do something else to simplify that? The answer is yes, isn't it?
Is the
If we invert and yes, go ahead.
We're going to invert and multiply, aren't we? So we're going to get 9 over root 9 minus x squared. We invert this and multiply. So we get 1 over 9 minus x squared. Okay. So now I get 9 over. Now when I combine root 9 minus x squared times 9 minus x squared, what am I going to get when I do that? That's an interesting problem, isn't it? Separate problem. Root 9 minus x squared times 9 minus x squared. What do we get there? And how do we work with that? We have a radical and a non-radical. Is there a way to combine those? Is there a way to multiply those? And how would we do that? I would suggest that if we change this to exponential form, that looks like 9 minus x squared to the 1/2 power, doesn't it? 1/2 power is the same as the root, is the square root. Here's the root, here's the power. And we'll multiply that times 9 minus x squared. Common base, and the exponent here is 1, but we'd like that to have a base of 2 so that we can combine them. So if this base is 2, what's the numerator to make this exponent 1?
2.
2. So now I have this common base of 9 minus x squared. And if I add these two together, 1/2 plus 2/2, what do I get?
3/2.
Yeah.
3/2. Okay, it looks like that. And that's in the denominator here, isn't it? So if I put that back into radical form, I'll look like the square root of 9 minus x squared and that quantity cubed. Okay. And one thing I want to point out here is you can see how messy this tends to get. And when you're doing a test and you're writing really fast, it's even going to be messier than this. So the idea is that's why I always need you to show me where your answer is. My answer is right here. And I put a box around it. So then I can always check, here's the answer. And is there any work to get there? Yeah, there's lots of work. So please be sure you show me where your answer is and you show me your work. Okay.
Will a box suffice, or do you also want us to put the arrow?
I also want you to put the arrow because there are many times, like up here, I might have a box. Who knows where I've got boxes and circles and who knows what. So
Okay.
I just want to be very clear that I know where to look to find your answer. And that shows me I must look right here to find your answer. Okay. Let's see. I think at this point, 433. I think I should probably go on to P.7 to make sure we get enough of that. So I'm going to stop here, go on to
When
P.7.
all this homework due?
It's always due the next day.
So all 3 chapters are due on Wednesday?
3 sections. Yeah, 3 sections.
Okay.
And each one has 10 problems. So we're talking 30 problems. And as we've gone through them, I think we've found out that the problems really weren't that difficult. There's more. Most of these homework problems, I'm hoping that when you look at them, you're going to be able to move through them fairly quickly because we've covered them in class and there are also examples in the book. Okay, P.7 talks about equations. And we want to be able to solve linear equations in one variable, and we might want to do it with equations containing fractions or rational equations with variables in the denominator. Solve for a variable, We might want to have an absolute value. We might want to solve quadratics by factoring, by square root property, and by completing the square. That's another one that we want to make sure we're aware of. And then solving by the quadratic formula. And we'll see if we all remember what the quadratic formula is all about. Okay, so we have a little over a half hour to go here. We'll stop at 5:10. So let's solve a linear equation. So if I give you the equation 2 times the quantity x minus 3, and I subtract 17 from that, and I say let's set that equal to 13 minus 3 times the quantity x plus 2. So I distribute this 2, and I say, well, that looks like 2x minus 6 minus 17. And the right side, 13 minus 3x minus 6. Now we want to gather terms. So we'll gather our x's. We have 2x and add 3x to each side. I get 2x and 3x. That's 5x equals, on the right side, I've got 13 minus 6. On the left side, I've got both negatives, so I'll add those to each side, plus 6 plus 17. Plus and minus 6, those are going to cancel, aren't they? 17 and 13, 17 and 10 is 27, and 3 is 30. So I've got 5x equals 30, divide through by 5, and I'll get x equals 6. And I'll say greater, there's my answer. Okay, questions on what we did there?
Could you repeat that second part where, like, I don't know how to describe it, but like the second part was like 13. There's minus 6 here. That section a bit lower.
This one here?
Lower.
This one
So the
here?
right side of the third one. Yeah, the 13
Okay.
area. Could you describe
All right.
that part more?
All right, what we're doing is resolving 2x minus 6 minus 17 equals 13 minus 3x minus 6. That's what we ended up with here. And now we want to gather terms. So I'll say gather terms. And when I gather terms, I'm talking about like terms. So here's an x, so I have 2 of those. And here I have a negative 3x. And I want those all on the same side, and I want x to be positive. So if I add 3x to each side, I get 3 and 2 is 5x, and over here, those will cancel out, won't they? Here I have negative 6 and negative 17. That's negative 7 and 6 is 23 equals 13 minus 6. That would be 7, wouldn't it? Positive 7. Okay to that point?
Yeah, I'm okay.
Add 23 to each side, and I get 5x equals 23 and 7. That should be 30. Divide each side by 5, and we get x equals 6.
Okay, I get it now. Thank you for walking
Okay,
through.
sure. All right. Other questions before I go to the next one? Let's say I have fractions. And you want to solve a linear equation in fractions. And I say, well, let's create some fractions. X plus 2 over 4 minus x minus 1 over 3, and set that equal to 2. Say, well, let's see, how are we going to figure this out? Well, if we're going to combine these two rational expressions, we need a common denominator, don't we? So it looks like our common denominator might be 4 times 3 or 12. So to get a 12 over here, I multiply 3 in the numerator and 3 in the denominator. That'll give me a 12. And over here, I multiply 4 in the denominator and 4 in the numerator. That'll give me 12, and that won't change the values. So now I have 3 times x plus 2. So that's 3x plus 6. That's over 12. Minus 4 times x. So that's, let's see, I'm going to say negative 4x minus 4. I'll leave this negative out in front here. 4x minus 4 over 12. Set that equal to 2. So now on the left side, I have my fraction here and a fraction here, and they're both over 12. So if I multiply everything on the left side by 12 and the right side by 12, that 12 will cancel, that 12 will cancel, and that becomes 24, doesn't it? So now I have 3x plus 6 minus 4x minus 4. So I'll distribute this negative. So that's negative 4x. Negative times a negative is a positive 4 equals 24. So now I have 3x and a negative 4x. So that gives me a negative x plus 10 equals 24, or negative x equals 24 minus 10 or 14. But I'm not solving for negative x. I want to solve for positive x. So I can multiply through by negative 1, and I'll get x equals negative 14. Okay, everybody okay with that? Questions? So there we solved a linear equation in fractions. Okay. Let's see here.
Sorry,
Here's it.
can you put the sheet back? I didn't catch the last part of the problem.
Let's see, was that,
All the way at the bottom.
let's make sure I've got the right one here. Is that, do you want this one?
I think it's all the way at the bottom, literally just the last thing we just finished.
Let's see, which one would that be here? Is it on this sheet you want to see? What was the problem that you wanted to get through? What concept did you want me? I'll write it down again.
I just needed to finish writing down the last part of it. I didn't get the answer.
Oh, okay. Let's see. Were we doing let's see, we were solving x plus 2 over 4.
Yes, that's the one.
Okay, x plus 2 over 4 minus x minus 1 over 3 equals 2. What do we have for a common denominator?
I just wanted to finish copying what you had down on the other page. I don't need to go through the entire thing again.
Okay, so 3x plus 6 minus 4x plus 4 equals 24. Are you able to solve that for x?
Yeah, that's the part I just need to write down.
Okay.
It's also in the book, detailed step by step on page 90.
Okay, perfect. Thank you.
Okay, other questions before we go on?
Back on the other page, why'd you times like the top part by 12? Like, don't you do it both sides as well? Does that make sense?
We did that to get rid of the denominator. So if we had 3 and 3 and 4 and 4, we would get 3 times x plus 2 over 12 minus 4 times x minus 1 over 12 equals 2. And I wanted to get rid of this 12.
Okay.
And I do that by multiplying each value by 12.
So would you also have to do like 12 times 3 as well, or no?
You have 12 times 3, but I'm not going to do the multiply. I'm just going to put the 12 there because I want to cancel out this 12.
Oh, okay.
So that 3 remains. This 4 remains. And then the 12 times 2 is 24.
Okay.
So then we go through and distribute the 3x plus 6 minus 4x plus 4 equals 24. Negative x plus 10 equals 24. negative x equals 14, or x equals negative 14.
So you only multiply both sides to like change the denominator, and after that you only do one side to get rid of it. That makes sense.
I multiply through by 12. So
Okay.
this 12 times this term to get rid of this 12, 12 times this term to get rid of this 12, and then 12 over here. Because whatever we do to the left side, we have to do to the right side.
Are we able to factor the 3 and 4 and then do the get rid of the 12 on the denominator? Like, does it matter if we do that first or second?
No, you can do it in any order you want.
Got it. Thank you.
Sure. As long as you come up with x equals negative 14, the way you do it is up to you. There are multiple ways to go through these problems. I'm just taking you through one way. If you've got another way, that's fine. Okay. Let's say I have a rational expression, and I have, meaning I have a quotient, and I have, let's say I have 3 over x plus 6 plus 1 over x minus 2. And I say I want to set that equal to 4 over x squared plus 4x minus 12. And in order to do that, I'm going to have a common denominator on all 3 of these terms. So I say, well, I've got an x plus 6 and an x minus 2. Well, I know I'm going to have an x minus 2 here in the denominator, which means I'm going to have an x minus 2 here in the numerator, because whatever I do to the numerator, I do the denominators. Similarly here, I'll have an x plus 6 and an x plus 6. So now I have x minus 2, x plus 6, x minus 2, x plus 6. That's good. So these have a common denominator. Let's see what's going on over here. Well, I've got a trinomial. So let's go ahead and factor this trinomial. So I start out with an x squared. So I'm going to have x times x. And then I want to get a 12. And I say, well, how am I going to get that 12? Well, I could do an x plus 6. I'll just make this quicker, an x minus 2. And how did that work for me? Well, first I FOIL it. And I do first times first is x squared. Last times last is negative 12. Outer is negative 2. Inner is positive 2. Positive 6. So positive 6 minus 2 is positive 4. So now the denominator on the right-hand side becomes x plus 6 times x minus 2. And fortunately, this denominator is already the same as this denominator, isn't it? So I can cancel that out. And the way I cancel it out is to multiply through by that denominator. When I do that, that gets canceled out. And I'm left with 3 times the quantity x minus 2, which is this value, plus x plus 6, which is this value, equals 4. Then I can distribute the 3, and I can say, well, that's 3x minus 6 plus x plus 6 equals 4. And I can combine terms. 3 plus x is 4x. We'll notice that this negative 6 and positive 6 cancel. So 4x equals 4, or x equals 1. Just divide through by 4 and I'll get x equals 1. And that's my answer. Okay, questions on that?
So I'm confused. Like, I understand getting to that point, but what about excluding numbers? With this type of problem, you wouldn't say 2 and negative 6 and the denominator up top are x is not equal to those?
Well, keep in mind what it asked you to do.
Okay.
It just said combine this value and this value. Okay, and if I combine this quotient or this rational value here, which is an a over b, if I'm just asked to combine those, I mean, you could say if you want to exclude them, That's true. But what happens, we're not saying x equals 1 with the exclusion. We're just saying when we combine these and solve, we get x equals 1.
So when in a problem where you're getting excluded stuff, it will ask us what numbers are excluded. Is that
Yes. In general, you should see something that says what values are excluded.
okay? Thank you.
Sure. Other questions?
I kind of lost you after you multiplied, like after you made the denominators common.
Okay, that leaves this value here, 3 times x minus 2 plus x plus 6 equals 4. Are we okay to there?
So what was the original second term? Was it 1 over x minus 2 or
Yes,
4?
yes, 1 over x minus 2, that's correct. And we multiplied numerator denominator by x plus 6 so that we would have the same value in the denominator. And if we multiply denominator by x plus 6, then we have to multiply numerator times x plus 6. So that's 1 times x plus 6, which is that's shown here.
Okay. So how does that equal 4? But
4 was on the right-hand side here. 4 was over the same common denominator. We eliminated all the common denominators. The way we do that is multiply everything through by x minus 2 times x plus 6. So if we multiply this side by x minus 2 times x plus 6, those will cancel. Multiply this by the same value, those will cancel. Multiply this by the same value, those will cancel. That's how we get rid of the denominator.
okay, could you please try doing maybe another similar problem?
Well, let's see here what I've got here. Let's take a look. Let's say we solve the following. 1 over x plus 1 equals 2 over x squared minus 1 minus 1 over x minus 1. Now, in order to solve this rational equation, we're going to have a common denominator. So the question is, what's that common denominator going to be? This is an x plus 1. This is an x minus 1. So we know we're going to have to put values in here and here. What does this thing look like? Well, that looks like, as we've seen before, that's x plus 1 and x minus 1, isn't it? So we have the second term here, x plus 1, x minus 1. So this value, what does this value need in order to have this same common denominator? What has to go here?
X minus 1.
And if we put x minus 1 in the denominator as a multiple, then we have to put x minus 1 in the numerator. That way we don't change the value. And here we already have x plus 1, x minus 1. So new volunteer, what do we need over here?
X plus 1.
X plus 1.
X plus 1 and x plus 1 in the numerator as well. So now all these denominators are the same. I can multiply through by that and cancel them out. So now I have x plus 1 equals 2 minus x minus 1. Now I just simplify. 2x equals 2 minus 1 minus 1. Is that what we're going to get here?
Minus 1.
So we get 2x minus a minus 1. What are we going to get here? So we've gotten rid of the denominator, and I have x
So x
minus 1
times 1 is it x plus 1 you wrote right there?
right here. This is going to be x minus 1, isn't it? This 1 times this is x minus 1. So I'm going to x minus 1 equals 2. That's this thing. And then we have to subtract this thing. So that's going to be 2 minus x. And then what do we have here? Minus 1, right?
Correct.
All right. So we have a -1 on the left side of the equal, -1 on the right side of the equal. Those are just going to cancel, aren't they? We got a negative x here. We bring that to the left side, makes that a positive. So on the left side, I have 2x. On the right side, I have 2. And these things have already canceled. So I have x equals 2, don't I? 2x equals 2, or x equals 1.
Wait, where did you get 2x?
I had a negative x on the right side and a positive x on the left side. If I bring this negative x to the left side, it becomes positive. Am I right?
You're adding an x.
Yep. You bring this x from the left side to the right, from the right side to the left side. How do I get it there? By adding an x to each side.
So how did you get rid of the denominator?
I multiplied through by the denominator. If I have a over b plus c over b equals d over b, I can cancel those out. And I can do that if I multiply each term by that denominator. B over b, b over b, b over b. That gives me a plus c equals d.
Professor.
Yep, go right ahead.
That's what.
And anyone in class, feel free to correct me if I'm wrong here, but it feels to me like people are getting hung up on making a common denominator versus eliminating the denominator. We're doing two different things. To create a common denominator, we're multiplying by 1, essentially. So if you look at that first step, it's x minus 1 over x minus 1. That's where we're creating a common denominator. The second half of this is eliminating the denominator by multiplying by that denominator. They're two different things, but it feels to me like people are getting hung up on that. So
Well,
maybe
let's just take one. Let's just take the first term, x over x plus 1. If I multiply the denominator by x minus 1, then I have to multiply the numerator by x minus 1. Now I haven't changed anything. So I have x minus 1 over x minus 1 times x plus 1. Now, if I were to multiply this thing by x minus 1 times x plus 1, this cancels this, doesn't it? So those are the two steps that we're doing here. Creating a common denominator, which is this value, and eliminating the common denominator. That's what we did here. That's what we did here.
Thank you, Professor.
Are we eliminating to get it in simplest form? Is that why we're doing it?
Well, we're doing it to be able to solve for x. We want to solve this thing for x. So yes, we're simplifying so that we can solve for x. Questions? We can keep.
We're not showing our work on multiplying that out by like the common denominator to get rid of it or stuff like that. Are we going to be counted down?
No, you're not asked to multiply this times this. You're just asked to create the common denominator. So what that does is that changes the value of the numerator, doesn't it? By creating a common denominator, I also have to change the numerators.
I mean, eliminating, like if you're not writing down x minus 1 times x plus 1 on each different denominator that you're multiplying it by to eliminate it, do you get graded down? Like you didn't show that in here, the B. You didn't show your work. So
here's the B.
That's where
B. There's B. Yes, I did show my work. Here it is, here it is, here it is.
Patrick, the answer is no. You don't have to do that because it's given.
It's not given. You created it by multiplying by x minus 1.
I'm saying some people might get hung up because you're saying that, but you didn't show it. And that's what might be confusing for some people. That's it. That was just my explanation.
Didn't I show it here? That's where I did the multiply.
I think we're having a communication break. Sorry, Professor.
We need to create the common denominator. That's what we did by multiplying here.
I'm talking about eliminating the denominator, not creating the common after you've done that.
All right. So now we have a common denominator here and here and here. Those are the common denominators. Am I right?
So what Patrick was saying is we then do not have to go through and show a follow-on step where we multiply each of the numerators by that denominator. We don't have to show that step of multiplying each thing. Okay, thank you.
No, you don't. And the way we're doing it here is we're saying let B equal x plus 1, x minus 1, and that would look like this. And then this is just to show you how we got rid of this. This is just a simple example of how we would get rid of this. But yes, you don't have to show it. We can just cross those off and say those will cancel out. Now, if a student were to say, well, how does that cancel out? Well, it cancels out because you multiply the numerator by that value in all three steps. That's how you get rid of it.
And why are you multiplying by the x minus 1 instead of x plus 1 like it was?
That got us the common denominator. Let's take a look at what the example was. We had 1 over x plus 1 equals 2 over x plus 1 times x minus 1. And we subtracted 1 over x minus 1. In order to combine these, we need a common denominator. These are not common denominators. This has an x minus 1, x minus 1. That's good. This doesn't have an x minus 1, so we need to add that. So here's x minus 1, and we have to put it in the numerator as well. So now we have an x plus 1, x minus 1. That's good. X plus 1, x minus 1. This has just an x minus 1, so it needs an x plus 1. So I'll put an x plus 1 in the numerator and denominator. Now every denominator is the same. And now we can eliminate them by multiplying through by that denominator, and that will cancel those out. Now we're left with just this equals this minus this. Questions? Okay, if there are no questions, I'll just keep going then. One thing I want you guys to be able to do, if I give you in fraction form 1 over, for instance, P plus 1 over Q equals 1 over F. These could be any variables. And I ask you to solve for P or Q or F. I would like you to be able to do that. So let's just take the first one. Are we able to solve this for P? And if so, how are we going to do that? And I'm going to step you through how to do that. Then I'll ask you to see if you're comfortable with solving for Q. So I'm going to say 1 over P equals 1 over F, and I'm going to move this Q to the other side, minus 1 over Q. I subtract it from each side, therefore it's a negative on the right side of the equal. And now I want to put these on a common denominator. This denominator is F, it needs a Q. So I'll say QF, and I'll put a Q up here in the numerator. This needs an F, so I'll say QF, and I'll put here an F in the numerator. Get rid of that 1. So now I have Q minus F over Q times F. So 1 over P equals Q minus F over Q times F. But I want to solve for P, not 1 over P. So I'm going to cross multiply. Cross multiply says I go this way and this way. Is everybody familiar with the term cross multiply?
Yes.
Anybody not familiar with the term cross multiply? Okay, so if I'm going to cross multiply, I'm going to move this QF to the numerator on the left side, Q minus F to the denominator on the left side, and P to the numerator on the right side. And I get, when I solve, P equals QF times over Q minus F. So I started out with 1 over P plus 1 over Q equals 1 over F. And I solved for P by going through this step and getting P equals QF over Q minus F. Now you should be able to solve for P or Q or F in that same fashion. Okay. That makes sense to everybody?
Quick question.
Yes.
Oh, she can go first, whoever that was.
Go ahead.
Oh, okay, I'll go then. So for to get P, did you basically just like invert it? Or is it something else?
Well, I cross multiplied. I took
Okay.
this and cross multiplied. So I start off with 1 over P and the quantity Q minus F over QF, and I cross multiplied. I went that way and I went that way. Now I can go through the cross multiply step if you want.
Please.
You go over that. Yeah.
Yeah, okay. So the cross multiply step would look like 1 over P equals Q minus F over Q times F. So because I want to solve for P, I'm going to multiply through by P. So I'll put a P here, and I'll put a P here, which is in the numerator. Now I've done the multiply on each side. Those are going to cancel. So now I have 1 equals Q minus F over Q times F times P. Now I'm going to multiply through by QF. So QF and multiply over here by QF. Those cancel. And now I get QF equals P times Q minus F. But I want just P. Okay, so I'm going to divide through by Q minus F on each side. Those will cancel. And now I'm left with P equals Q times F over Q minus F. Okay, questions?
Could you please show again how you went from 1 over P equals Q minus F over Q times F to P equals Q times F over Q minus F?
That's what this is.
Yep, I didn't quite get that, but
All right, we'll do that after class. You and I will talk about that. You want to be able to go through these steps, and we'll go through that individually with whoever needs to go through that. Now it's 5:08. We just have a couple of minutes left. Any questions, anything we covered before I talk about another topic here that I want to review just to help you with your homework? And this will cover after class. Okay, I want to talk about one other thing, which are absolute values. If I have 5 times 1 minus 4x, let's say minus 15, equals 0, and I want to solve for x. Before I solve this, I want to say, well, I know that if I have some value u equals some value, the absolute value of some value u equals c, then that says that negative u equals c and positive u equals c, because this just says I only want the absolute value. So whether u is negative or positive doesn't make any difference. It's always going to equal this. Okay. So if that's the case, I can use that same example over here. So I can change the form of this one to say u equals negative c if I multiply through by -1. So in this case,
recording
u can equal
stopped.
c or u can equal negative c. Either case. And I'll just take this out because the positive doesn't have any meaning with inside the ampersand, or inside the vertical bar, because this means absolute value. meaning just the magnitude. I just want the magnitude. I don't want direction. If I apply that concept here and solve for just 1 minus x, I get absolute value 1 minus 4x equals, move the 15 to the other side, 15, divide through by 5, and I get 3. So I get absolute value 1 minus 4x equals 3. But from here, I know that this can be positive or negative to equal this 3. So I can say 1 minus 4x equals 3, and 1 minus 4x can equal negative 3. Okay, by that same logic. So that says moving this to the other side, 4x equals, move this to the other side, negative 3 and positive 1. So 4x equals negative 2, or x equals negative 1/2. Okay, now everybody follow what's going on there? On the right-hand side, we get 1 plus 3 equals 4x, or 4 equals 4x, or x equals 1. So then we would say x equals negative 1/2 and x equals 1. Those are both solutions. Okay, it's 5:11. I'm going to stop at this point. Everybody is dismissed. You can leave. However, I'm going to stay for another 30 minutes or up to 30 minutes, depending on what kind of questions you have. Okay, now when am I going to see everybody next?
Wednesday.
Wednesday.
Professor.
Okay. Yes, we'll see you Wednesday then. And for those of you who have questions and want to stay after, we'll do that as well. Okay, everybody, see you Wednesday. Good work.
Thank you, Professor.